So today we're going to be talking about how Snowplow Analytics manages private SaaS infrastructure at scale across 150 plus Amazon and GCP clients. But before we get into that, who are we? So my name is Josh. I'm the technical operations lead here at Snowplow Analytics.
Hi, I'm João, site reliability engineer, and I write Terraform code at Snowplow.
Quickly, what is Snowplow Analytics? So we're an open source data collection platform. What our product does is lets you collect really granular, high quality event level data from all of your websites, apps, server-side tracking. Anything you want to track, you can track with Snowplow. We're not going to get into all the amazing things you can do with Snowplow, but we will talk about the fact that it's composed of lots and lots of different systems. So from an orchestration point of view, this is quite complicated. We've got a lot of things that we need to stitch together, from collection through data validation enrichment, storing that data, modeling that data, and then analyzing that data. We help organize all of that. To complete the picture, we're going to talk as well about what private SaaS is and how it looks at Snowplow. So for those not familiar with it, private SaaS is like SaaS, but rather than having a multi-tenant environment, every client has their own environment. Every client has their own stack, everything unique, everything sandboxed. So that means that every client has different volume and different scaling requirements. They have different peaks, different troughs, different requirements entirely. Every single one of these 150 clients has something different. And they're also all not quite the same. They've got different components, they've got different combinations of components. It kind of matters, what they're trying to solve, and it all varies. To add to the picture as well, all of these environments can fail at the same time due to things that are outside of control, like cloud failures. And you'd be right if we had questioned why we do this to ourselves occasionally. Speaking then about how this links with the HashiStack, we had a lot of problems we were trying to solve. So lots of components that need to be configured together. We've got everyone deployed in a private SaaS model, and that's not going away. That's something we enjoy. That's the model that we choose to run as a company. And we've got hundreds of environments and hopefully some point thousands that we're going to need to manage. So this needs to scale up and needs to be secure. We need to support interactions with this infrastructure from lots of vantage points. This leads us to our reference architecture as of today. So currently what we have under the hood is console and Vault for our metadata and secret management. We have Nomad, which is our kind of generic job scheduler. And then we have Terraform that kind of brings all the bits and pieces together. It's not Terraform how you would write it in a traditional sense. It's very generic. So all of the ways that we configure it are done in the console and Vault metadata layer. And all the Terraform is really just a generic stack that we can apply in lots and lots of different ways. The only bit that we've kind of custom built, I guess, in the middle is what we call our deployment service. So this is a very thin authenticated API layer that lets us submit jobs to Nomad to then trigger the deployments, to pull the data from console and Vault, and then to deploy out to our AWS and GCP cloud environments. The current two implementations we have of that is our Slack bot called Snowdroid, as well as some integrations with our Insights UI, which is kind of our SaaS portal into all of this infrastructure. I've talked long enough, and I'm going to now hand over to João to do some actual work and show you how we deploy a Snowplow Mini. João, over to you.
Cool. So I'm going to show you how we deploy a Snowplow Mini. But before that, we need to talk a bit about stacks dependencies, topologies, workspaces, and console migrations. After that, we'll be ready to deploy the minis. Stacks is a concept that we have created at Snowplow, and it's an abstraction on top of Terraform code that allows us to build dynamic infrastructure. The best way to understand what is a stack is to look how it looks in code. And for that, we have here some screenshots. We have the stacks that we are going to use for this demo, the AWS setup and the AWS Mini. And you can see here on the top left image, the stacks. And for the AWS setup stack, we have 3 folders. One that has the version, and the version is where we do the Terraform init and the Terraform applies. And then we have the migrations. We'll talk a bit more about this in the next slides. And then we have the modules. The version folder is also where the code that orchestrates all of the deployment is, and the submodules is used to organize our Terraform code. On the right, you can see the content of the submodules, and we like to organize it using the cloud services names. So you can see here, for example, a folder named EC2. This is a Terraform module where we store AMIs, Bastion, keys, and we also have an IAM folder where we store code that creates roles and policies. And for example, if we were using other AWS services, we would have, for example, if we were using ECS, we would have a folder for ECS, and there we would have code to create the ECS cluster or tasks or the ECS services. Here on the bottom left, we can see another stack, the AWS mini stack. And the first difference that we notice is that we have several versions, and we create new versions every time that we need to do a breaking compatibility change. This is important because it allows us to have some customers on one version and another customers on another, and so on. And this is quite important because as we have hundreds of customers with minis, we aren't able to upgrade them all at the same time. Other than the versions, we also have here some templates folder where we store configs for the Terraform, and then we have an upgrade folder where we store scripts to do some upgrades. Now let's talk a bit about stack dependencies. You can see here in green the stack dependencies for Mini. This means that to deploy the AWS Mini 060, you need to deploy first AWS setup or 4.0. The Mini stack deployment is a quite simple deployment, but if you look here on the right, you can see an example of a more complicated one. And the way to read this diagram is to start on the right and follow the arrows so that we understand the dependency order. So for example, if we wanted to deploy the AWS metrics relay, we would have to follow the arrow into AWS RT pipeline, and then we would follow the arrow and AWS setup. So we would have to do the Terraform apply first for the AWS setup, and then Terraform apply for AWS RT pipeline, and then Terraform apply for AWS metrics relay. We also have optional dependencies. For example, you can see here in AWS Igloo that the line is not continuous in the arrow. So if the customer chooses to have an AWS Igloo server, we would have to deploy it first before deploying the AWS pipeline. Then let's get back here into the left side, into the blue part of the diagram. And here it's represented the deployment topology that we are going to use for the demo. And we'll be deploying 3 minis into the same AWS setup. This is quite cool because it allows us to reuse infrastructure. So we don't just reuse code, we also reuse the infrastructure, which is quite cool because we only have to deploy the AWS setup once and then all the minis use it. The next thing that I would like to talk to you about is workspaces. So Terraform workspaces usually are used to manage the environments like production environment, staging environment, or development environment, but we use them also to manage the customer. So our workspaces are a combination of customer and environment. As you can see here on the top image, we have a list of workspaces, and on the right side in red, it's the customer name. These are example customers. And then on the right, we have the environment name. And to understand how we work with this in Terraform code, on the bottom, we do have a bit of Terraform code where we use this information. So, and we use it like this. So we fetch the workspace name into a variable, and then we split it by underscores, and the customer name is all the bits until the last underscore, and the environment name is after the last underscore, the remaining bit. This is quite important because it's what allows us to connect into different AWS accounts. So based on the customer name, we do a lookup to the assumed role that then the AWS provider will use to connect into the customer account. On this slide, we can see console, and if we look here on the top in the blue letters, we can see that we have the path to the console key, and it is using the information that we have in the workspaces. So we have the customer name, and we also have the stack, and we have the environment. So the Terraform code using the customer and the environment, and then also the stack name where it's running, builds a string that is being used to come into console and fetch the configuration values. This is how we store the configuration for hundreds of customers, and hopefully it will support thousands of them soon. Let's go next. As you might be guessing, these are a lot of console keys, and we aren't adding them all manually. So we have built a program to manage the keys in console for us, and we have called it console migrations. Console migrations work very similar to database migrations for normal SQL databases. And you can see here the contents of the migrations folders of one stack. These are Python scripts that are versioned by date. And you can see here on the right an example of a migration. Let's just see what this migration does. So we are declaring a key named EBS encrypted. So for the mini, this means that if the hard disk should be encrypted or not, and the default value for it is 0, so by default the encryption is disabled. We have here text where we generate help documentation from it, and then we have some more data for it, and we have here the type of key, if in this case is integer, what values can we have in there, 0 and 1, and if it's required or not. Now, before we start the demo, just let me recap what we are going to deploy. So we are going to deploy 3 minis into AWS, and we are going to reuse an environment that Josh had already created previously for these tests. Okay, for the demo, I'm going to pull up here the CLI. And the first thing that we need to do is to set up console. So let's go into the migrations folder for the mini. Here we are. And then let's run the migration command just for you to see what it's required to run. So we need the customer name, the environment, and the region where it's going to be set up. Now, let's fetch the actual commands that run the migration. So for that, we have here 3 bash commands that will set up, each one will set up a mini in the EU central region. We also have the option no dry run, so when we run it, it will really create the keys in console. So it's running, and it's having at this moment probably 100 or 200 keys into console with all the configurations that's possible to do to AWS mini stack. Okay, it has finished, cool, no error, it's always good. Okay, now let's jump into console to see what has been created. And we can see here that the 3 minis inside of AWS Sandbox were created. And now what we need to do is just change one default value, and it's the environment name. And this configuration, what it does is it's going to be configured to reuse the Josh AWS setup. So we go over here and we change it to Josh because that's the environment name for the AWS setup. Okay, mini 1 is done. Now we need to do the remaining minis. So let me input here the value on the browser bar. Okay, let's go into mini 2, into the environment name, input Josh. Okay, let's save. Now let's go into the mini 3, setting up also the env name. Okay, let's input the value. Okay, cool. And now we have all of the configuration done to deploy 3 minis. It's not needed to do any more configurations because the default values that we have work well enough for the demo. Now we need to step out secrets because this stack also uses secrets, and we store the secrets in Vault, and we have just stepped out. We have inputted a secret for mini 1. Let's do the same for mini 2, and then the same for mini 3. Okay, at this moment, Vault is also set up. What we need to do now is to run Terraform, and we'll have our brand new minis ready to be used. Let's go into the version of the mini, 060. We need to do Terraform init. Let's run the Terraform init. So it's initializing all of the submodules, connecting to the backend, fetching the providers. Okay. Now we need to create workspaces. We are here using AWS Sandbox, but if this was a real customer, the customer name would be there. So it has created the first workspace, creating the second one. Okay, it's almost, okay, cool, it's created. And finally, what we need is to do the Terraform applies. So there's this trick that I usually do to do multiple applies. So it's just a bash command with all of the commands. And it's starting to run the Terraform apply. So this part is going to take a bit. So let's fast forward onto the final after the Terraform has applied. So the minis have ended the deployment. All went well, and we have here the URL for one of the minis. Let's test it out if it worked out okay. So let's input it here in the browser, and if we see a username and password box, it's okay. Okay, cool, it has appeared. So this was the demo. I'm passing out the word now to Josh so that he shows you how to avoid doing all of these manual steps that I've been doing to set up the 3 minis.
Thanks, João. Thanks, João. Yeah, so what we've shown there is a very classic way of deploying Terraform. You're in the CLI, you're running Terraform apply, going through all those stages to, initialize, stub things out, upgrade, apply, all of those kind of steps. What I want to talk about now is how we do more mass deployments and with a lot more automation on top. And how we do that, and what we're going to demo today is upgrading all the minis that João just deployed to a new version. We're going to be doing that on top of Nomad, and we're going to be kind of interrogating Nomad logs, and we're going to visualize how the deployments are going in Grafana. Before we talk about that though, mass deployments are very scary. You've got kind of potential incompatibilities. You've got whether or not the current state of the environment is correct. So has it drifted from what you expected to be? Is the upgrade safe to apply? The security of it, obviously. With a mass deploy, you can do a lot of damage. In João's example, it's kind of one at a time. It's quite safe. It's human driven. Here we're talking about robots deploying lots and lots of changes that might not be very possible to stop. To be clear, we haven't solved all of these problems perfectly. It's very much a work in progress, but we've got a good base now that we're starting to build things out like drift detection, like automatic upgrades that we hope to make safer and safer over time. So what we can see here is the 3 minis that João has deployed are now all reporting healthy. We can see this by the healthy host count. There's 1 of each, which is exactly what we expect. Very low CPU utilization. It's not doing anything at the moment. These are kind of just dead waiting servers. And we can see about 12 2xx requests per interval. And this is just the normal CloudWatch health checks that we've got configured to check that everything is alive. So it's fairly aggressive health checking, but we need to make sure that everything is looking okay. What we're going to do now, though, is we're going to upgrade these minis. So we're going to switch over to Slack. And here we've got a special channel just for Snowdroid. What we've got here is a transaction block where we're going to submit 3 commands to deploy AWS Mini upgrade for Mini 1, Mini 2, and Mini 3. When we hit submit on this, all of those jobs are going to land in Nomad. We can follow the links here that have been provided to go directly to that Nomad job. But for the sake of this demo, I'm just going to switch straight over to something I've prepared earlier, which is the Nomad page. Here we can see that all of them are running. They're all currently green, so everything's kicked off correctly. And we can now go and interrogate the logs of the Terraform deployment. We can do that for all the jobs, and we're just going to quickly have a look here. So by scrolling up to the head, we can see what is being applied. So we did some upgrades. We can see all the Terraform modules being initialized, just like they were on João's side. And we can see that things are now starting to apply. One quick thing with these is that it is a Terraform auto apply, so we do have a dry run mode of this as well. For this case, we've just gone straight for it and started applying them. As with João's demo though, this can take a while, about 5-6 minutes for it to apply, so we're going to jump forward in time and have a look at the finished product, which we can now see all the AWS Mini deployments are dead, they're finished. They all finished green, so we know that there's kind of a 0 exit code, which is exactly what we're looking for. We can then go in and interrogate the logs again, and hopefully here, yep, there we go. So the deployment's finished successfully, and we can see the AWS Sandbox Mini 2 endpoint. We can go through all the jobs that we submitted and go and have a look at the logs for all of them. So that was Mini 2. This one will be Mini 3. And then the last one will then be Mini 1. So all 3 have been deployed and upgraded successfully. So now that we know that they've also been submitted successfully, we also want to have a look at Grafana, because that's obviously where we're monitoring these things, where we're looking for the success of this upgrade. And what we can see here is that I was probably recording this demo far too late in the evening, but we can see a gap in the monitoring. So when we hit this deployment, what happened first is that 2xx requests went to nothing because we shut down the server to replace it with a new one. That took about 2 minutes to come back online. We've then got the CPU utilization that also dropped to the floor but came back to life. And then we've got the healthy host count, and that took a lot longer to come back to life. And the reason for that is just that our health checks are much lengthier than the time it takes to actually deploy the new server to make sure that it launches correctly. So we don't want to be too overeager. We don't want to be too lazy about it either. So everything returned back to health. So we've got a successful deployment of 3 minis in one Snowdroid command. So that's kind of the demo. That's where we are now. We do manage to do these deployments, not just 3 minis at a time. We're often doing 100 at a time. So we're doing a mass deployment rollout where we're then monitoring the health checks, the Opsgenie alarms, and Grafana dashboards to make sure that everything is working successfully. This does have some risk, so depending on what service we're upgrading, we'll do different amounts of mass deployment. But where do we want to take it next? So one of the struggles we're starting to have is needing to put automation on top of automation. So Terraform has modules which then, bring resources together, and we're now at a level above. We've got stacks that we need to start combining together, and there's no natural way to do that that we've found. So we're looking at building a tool we calling internally Snowtopia, which is going to be that level on top. So how do we combine multiple stacks in a logical topology to then deploy lots of these systems together? An AWS setup for 3 minis, we could script that. We could build that into an actual deployment, a recipe, for lack of a better word. This also opens up the chances to do easier multi-cloud deployment. So using everything cloud native, but starting to stitch all of these disparate systems together into one big multi-cloud pipeline deployment. And the most exciting thing for me and for the team, I hope, will be self-service private SaaS. So how do we let our clients manage their infrastructure in a private SaaS model without myself or the team having to execute anything? How do we let them manage their own minis, their own pipelines, their own infrastructure but Snowplow branded. And that's the future. So obviously, if you didn't manage to get all your questions in during the session, we'd love to still hear about it. So any feedback you have would be great. And thanks for listening.
Also, thanks for listening and see you next time. Bye.